There are certain things that are produced that are just simply the best and the workhorse of their industry. And in terms of a blow dryer or hair dryer, that's going to be this here Elchim 2001. This one's the turbo high pressure. I think that's the slightly upscaled version of it. They're made in Italy, extremely well made and extremely reliable. However, they do have their problems. The most common issue that comes up with these is the clog full of hair, and that'll reduce the airflow or get into the elements, and it'll just simply start burning and smelling. This particular one had an issue with the switch coming away from the circuit board where it was soldered on. And in messing with it, I caused another issue, which is I've snapped off the wire for the fan. And I'll show you how this thing comes apart because it's a little bit strange. And to determine that there was a problem with the element, I just simply used one of these plug-in kilowatt devices. This is a Chinese one. It's basically an inline power analyzer. Analyzer is a big word, but it's more of a meter, if you will. You can also just simply use a multimeter, and you can clip it onto the leads of the outlet. This is the one that has the built-in GFCI on it, and then play with the switches and see if there's a change in resistance. Now, I've already done all that. The most important thing here is going to show you how this thing comes apart. The clip is on this side, and then the logo nameplate is on the other. There's two screws here, and those come out, and those facilitate the holding on to both of these sections. Back here, there's two little rubber feet or grommets that hide two more screws that are in there. You got to kind of work them out with a tiny flathead screwdriver, and they look something like that. I've already taken out the screws, so I'll get the thing apart here and just show you how the whole thing comes apart. Once you get the screws out of these things on the side, they come out like that. See, this part has a bit of a tab, so try not to yank it if it's caught on anything. And then first thing you want to do is gently remove this, and the little diffuser's on there, and then this comes off of the element assembly, and I'll show you how that goes back on after. You do want to be careful with the little cone over here because you have these tabs. There's two of them, and you don't want to force that and snap these tabs off because that would not be a good thing. And then there's two tiny notches that line up here when you go to put the thing back together. I should also mention you want to make sure this thing is at a moment to cool down if you're messing with it, because the element can be extremely hot. And this is the point where you're going to want to carefully inspect and clean the element with a very gentle brush, and then hit it with some compressed air. And you really want to get in there and get every tiny little bit of hair that's jammed up in there. And you can see where the two elements come up here and they're joined, and then they go to the heat limit switch over here, which is also connected to the fan. So if the back becomes obstructed in some capacity, limiting the air that can be discharged through the element array and overheat it, it's gonna turn off. There's a diode over here. You can go ahead and check that. I did. And again, to get the whole thing apart, you got to make sure that these two screws are taken out. Now, at this point, the easiest thing I found is some sort of a case opener tool or something that's not going to mar this plastic, and you can just kind of work the clips open like that, and they'll release. You can see there's one here, there's another one over here, and another one on the other side, and then that slides out from the element assembly. And you want to make sure that these, actually there's only two of them, but again, you want to make sure that you don't force that too much. And at this point, you can even remove the entire blower assembly out of the back and clean it. There's a nut here that holds the fan on. It's 5/16, and you can hold the fan gently, loosen the nut, take the fan off, and clean in behind. Brushes are in there, and the switch assembly is here, and you can see that's that fan wire that I broke trying to mess with this thing. So it's good that we found that. And then here, so the power cord is held in. There's a strain relief here. There's 2 screws, and we can take that out. So now we've got the strain relief out, we can remove the board. And it wasn't apparent to me the first time, but this solder joint over here cracked, and I'll see if we can get that to turn up here. There it is. Right over there. Now, at this point, I'm about 90% sure that that's the problem. It'll be yet to be determined. And this fan wire, I'm not entirely sure where it came from. Looking at it more closely, and it appears to be right there. There's a piece of copper wire sticking out. So I'm going to go and quickly resolder these back in place, and we'll see if it works. Looks like it's solid tinned copper. And it did actually go right through the board in that hole there. So I think I'm going to get my solder sucker and try and get that crap out of there. That's better. Give it a bit from underneath too. That's on there pretty good. And now it's gonna be a matter of kind of reheating this one and adding a bit more to it. Presumably they didn't add enough. So the failure mode on this is going to be pretty apparent now, because you're relying on these solder joints here to take the brunt of the force of you pushing back and forth on this. So if this maybe wasn't seated correctly at the time of assembly, and that's to say that the plastic body of the switch wasn't seated against the PCB board and the force was being put against these solder joints, eventually with time, of you pushing this back and forth, maybe dropping it a couple times, it's going to crack that solder joint and it's going to let loose. Okay, so I think that's pretty good. I touched up some of the other ones a little bit. These are actually like twist sort of terminals. So once you seat the terminal through the board, you give it a twist with the pliers that locks it in, and then the solder makes the connection and holds it in place. It is actually a printed or a layered circuit board. That's why there's no wire going to that terminal. And again, these are for the fan. So now the fun part of putting the whole thing back together, which I'll show you that here as I go along. Okay, so first we want to make sure that this is all cleaned out and everything. And then fan. See, there's two slots here where these ridges fit in. That goes in like that. I'm sure at the factory they must have some kind of jig that holds this in there. And then we just want to kind of let the whole thing fall back into where it came from. So put the cord in with the strain relief. Being careful not to pierce or pinch any of the wires. So we'll screw those in. Okay, that's in. And now you want to kind of work the wires in between these little slots that are behind, being careful not to pinch or jam anything. And then this has two little pins that fit onto the top of the motor. That kind of sits in there like that. And you just want to evenly distribute these wires through these slots. And it's kind of what it should look like. And then we'll just carefully let that sit, and you can see where it wants to fit in between that, and then there's a tiny little notch in the post which fits through that hole over here, and that fan wire is kind of sticking up there, so I'll just nip that off, and I'll do that like this so that it doesn't fall anywhere it shouldn't cause a problem. So that's in there, and we want to make sure that the back of the fan spins freely and it's not locked up against anything. This is in there, and then when we go to put the cover on, it's not going to mash anything. We also want to make sure that these wires really aren't touching anything that's going to get hot, like these brush holders, or the ends of the brush holders. Windings of the motor, they can become hot, so we just want to kind of space these out as much as we can, really. Make sure that nothing's coming to direct contact with anything that might get a little bit toasty. Okay, so now that's in there, and what you want to do is take your cover plate, get that on there. Get the switches in. Get the clips. Make sure it's on evenly. Make sure the element is still sat where it goes. And these fins kind of fit in these slots here. And then this protector has a large void which sits at the top, and two slots where each clip will go, and then the retaining clips. I find it easiest to just put this guy on here, the diffuser, and you'll see that there's some ridges in there where that fits in, so you'll kind of have to twist it and turn it as you put it on to get it to fit correctly. And I'll show you that here. The bottom clip is going to go here, the other one at the top. So I'll put that in, and I just put my finger on here and twist it until it finds its ridges, and then I'm going to work the clips in. You have to pinch this a little bit, and again you want to make sure the ones on the side fit in as well. Keep that diffuser straight. Make sure that's on. And then this goes on here like that. And put your screw back in there. Same thing on the other side. And then your 2 screws back there. And then the little rubbers will go in there. I wouldn't push them down too deep. You just gotta put them in there to where they won't come out and where they'll cover that screw. You don't really need them anyway. They just kind of hide those screws in there. So I'll go ahead and finish putting the screws back together, and we'll test it and see if that works. Okay, one kind of preliminary safety measure we can make is check for ohmic resistance across the terminals, make sure nothing's dead shorted, or kind of pre-test what we're doing here. So I made sure that the GFCI is in the working position, because if it's tripped, it's not going to work. There are electronics in here as well, so don't expect these readings to tell you anything super accurate. But we'll go ahead and we'll put on fan speed 1, fan speed 2, and then element 1, element 2. You can see the resistance drops because we're making contact across those elements. And then the real test is going to be plugging it into this here. And we'll go fan 1, fan 2, element 1, element 2,